Hello guys, we are back again with another live stream. So today we'll be solving DSA questions again. I know we are solving again and again, but still what to do? We have to. So we'll be solving DSA questions today also, and yeah, this live stream will be for continuously for 8 hours, and we'll try to solve as much questions as we can. And today what I am thinking is I'll be trying to pick some hard level questions because easy and medium level questions are not that difficult to understand or to solve. It might be possible that there will be some medium level question also that is hard, but if I'll get that any type of question regarding to that, I'll surely solve that question also on the stream. But today what I'm thinking is I'll be trying to pick hard questions, and we'll try to solve hard question as best as we can. So let's try with some hard questions today. And this blind series what we started in the last stream, so we were not able to solve this two hard level questions. I can see there are not many hard level questions, but there are two hard level questions which we need to solve. These two hard level questions we already solved it. If you haven't seen uh, this video, this solution, you can check our old streams. You will get where we solved these questions. So we solved these both questions. We didn't solve this word search, so today we'll be picking up this word search also. We'll try this alien dictionary. We already solved this alien dictionary last time. So okay, so I'll try to pick the hard level questions today, and then based on that we'll move forward. So let me start my timer. And so what we basically do, we do 50 minutes of coding, and then we'll take a 10 minutes of break. This will be done for 4 times, and then we'll take a 50 minutes or 1 hour break for lunch, and after that we'll again continue to code. So let's start 0. So okay, so let's go and let's try to solve some good lead code questions. So the first question is serialize and deserialize binary tree. Let me open it in lead code if the question is there. Binary tree. Okay, so let's see what the question says. Let's open this also. Okay, yes, Saurabh, today 8 hours for sure. So we are given a binary tree. Your task is to create two functions. We have to create two functions. Okay, one for serializing the tree into a string format. So we have to serialize the tree into a string format, and another for deserializing the string and back into the tree. The serialization string should retain all the tree nodes and their connections, allowing for reconstruction without any loss of data. Okay. So what we have to do, we are given a root of the node, which is 1, 2, 3, 4 and 5. Saurav, is my audio clear or audible, or is it less? Can you tell me? So we are given some input string. Now what we need to do, we need to serialize it into a string. So we know uh, if there is nothing, then there will be none. We need to find some way to serialize it, so that if we want to deserialize it, we should be able to deserialize it back again. Correct. Okay. Mm. Okay, for serializing, can we go for level order traversal? Maybe if we try to think somewhat level by level, pick each level and put it in some string and go on. So suppose we have 1, we added 1 in our string, and then we popped this 1, we kept 1 in queue. Now we pop this 1, we put it in our string, we'll add its left and right to the queue. So we popped this 1 from queue, we added in our resultant string, we added 2 and 3 in our queue. So maybe we'll think of 1 and then it's left and then it's right. Okay. So if we do something 1 and then 3 and then 2, suppose we are doing something like this. So we are picking 2 this time. Now we'll add 2 in our resultant string. Now its left and right is null, so let's add its left and right as null also. Don't push it in our queue, but push it in my resultant. Okay, its left and its right are null, but there's one thing, how to read this string back. Now to read this string back, we need to do something. Somewhere if we will be able to make 1 and then 2 and then 3, so we know 1 is my root, its left child is 2, its right child is 3. Correct. Now we'll take this node, its left child, what its left child is null, its right child is null for 2. So its left child is null, its right child is null. Then we'll take 3. 3's left child is 4. 3's right child is 5. So 3's left child is 4. Right child is 5. Now this is null, this is null. Now we came to 4. 4's left child is null, right child is null. So it's null, it's null. We have 5. 5 left child is null, right child is null. So it should be null and null. So my string should be something like 1, 2, 3, null, null, 4, 5, null, null, null and null. Okay, so somehow we need to make string something like this. If we can make a string like this, we will be able to go back. To its original root. So somehow we need to make this string. Now how we can convert the given tree into this string? Correct. That's the main crux we need to solve. Let's see how can we do it. Serializing and deserializing. Okay, let's make it black screen. So we have been given 1. So we have given 1. Now it's left and right. One's left and one's right should be directly pushed in our resultant. If we are making a resultant, it's left and it's right directly pushed, and it's right and its left is pushed in my queue. So let's take queue. We have in our queue 1. We popped this queue, we pushed its right, its left and its right in our queue back again, and its left and right in our resultant also. Now we took this 2 out. Its left and right is null. We'll push its left and right as null. We'll pop this out. Now we'll pop this 3 out. We'll push its left and right as 4 and 5, and also 4 and 5 in our queue. We'll pop this out. We have 4. We'll push its left and right. Even if it is null, we'll push it. And we have 5. We'll push its left and right. And if it is null, will not push it in our queue, but I will push it in our answer. So somehow we got this up, and if we want to trace it back, we have 1. Its left and right is 2 and 3. Now we jump to 2. Its left and right will be these two, null and null. So we don't have to do anything. We jump to 3. Its left and right is 4 and 5. Went jump to null, we jump to null. We went to 4, its left and right is null. We went to 5, its left and right is null. Go back to the stream, Saurav, you'll get to know the question. I think I have already explained the question very clearly a while before. So this is how we will be using serialization and deserialization. So let's try and code it. Um, which platform should I go for? Should I go for lead code or should I go for this? Maybe I'll code it in my lead code and then leave. I'll do it. No, bro, a while ago. It's already, you are already very late. So we'll create a string resultant which will be initially empty. Now we'll declare a queue which will keep nothing but a tree node. Now I'll push my root in this, and while not queue dot empty, until and unless my queue becomes empty, as was I am watching stream on 2G, not 4G. Bro, if you'll watch on 4G also, you'll be able to watch my stream. I think 2G or 3G doesn't matter. You can watch my stream, it's free. So what we will do, we'll pop this node out. So let's take this node, from here q dot I think it's front. I'll pick the front and q dot pop. I'll pop this node, and in result one thing that I need to make sure, if root is not there, will directly return result, else result plus is equals root ka val. So it's an integer value. No network in mountains. Yes, bro, but are you in mountains? I don't think you are in mountain. What about your plates? How much plates you have now in your body? Okay, so I added the root node in my queue. I'll pop this. I have to add if node left is there. If node's left is there, I'll add that node in my result also. Node left val uh, it's left value plus 0. We'll convert it into string, and also will push it in my queue dot push uh, node left. If node left is there, if else there should be one else also. If node left is not there, then in our result I'll simply add n. That means it's null over there, nothing is there. Now if node right is there, result plus is equals to node right. So I'll add it in my result. I'll also push it in my queue. If node right is not there, that means I'll simply push it in my queue n. So this way we will be able to make a string, and then we'll return our result. So this will serialize our string and will return result. Now I have to deserialize it. We are given the same string back here. Now what I will do, I will have to create node, root node. So this, let's suppose this is my root node. This has been initialized with 0. Okay, so I should be having 2 iterators. Maybe iterator 1 will start with index 0, and iterator 2 will search for its left and right. So it2 should be equals to 1. It should start from 1. So I'll start from here. I is equals to 0. Now while my it2 is lesser than data dot size, it should be lesser than data dot size. I know that it1 is my root node. Okay, so one thing here, do we need to store it somewhere, or direct DFS can do the job? So I have this in my resultant. Now what I need to do is, do we need to so here it is my it1, and here it is my it2. Okay, these are the two strings. Now one, I'll create a new node that is 1. This IT1, suppose it's not an index, it's a node, so it will be pointing to 1. Here IT2 is from 2 to 3, so this is a value, so its left, IT1's left will be added with 2, IT2's, and then IT2 will move one step forward, which is over here, and then I'll add 3 over here. Correct. Now I'll do a DFS, and then I'll go to left. Where my IT1 is pointing. Okay, and my IT2 will move to here. My IT2 will be here. I'll check this is null. That means its left is null. I'll do nothing. I'll move my iterator again to the next pointer. Which is over here. Its right is also null. So we'll do nothing. We'll move my iterator pointer here. And it's both left and right was null. So we'll retreat back. And we'll do a right call for IT. So we have 3, its left is 4, so we'll add its left as 4. So we'll add its left as 4, and then we'll move to this position. We'll add its right as 5 because they are present, and then we'll move. Now its left and right are called. Now we'll go for a left call again for this. It's null and null both on its left and right, so my IT pointer will move here. We'll return back, we'll do a right call. Now it's left and right are null, so we can use DFS directly over here instead of doing something else. So what should we do? Let's start with my iterator. From 1 and tree node pointer. Which will nothing. Let's make this as root and this as node. This will be my okay. So I'll be making a new tree node with a value. I'll be sending it data of 0 minus 0. So this will convert it into integer, and this node, now this node will be pointing to root. Now I'll have to do DFS calls. So let's and at last I'll return root. Now let's make a DFS call. DFS call will take what? We'll take this node, we'll take the iterator, and we'll take the data. Let's make a DFS. It will return nothing. Void DFS tree node is a pointer. Int IT. And this is my string data. So if my IT goes beyond my data dot size, that means we are already completed, we have completed, so we'll return back. If not, we'll check if the current position value is null or not. If data of IT is not equals to null, that means it's left, that means node's left value is there. So what we will do, we'll add node left is equals to new tree node with data of IT minus 0. Now there's one more base case. If data dot size is equals to 0, that means there was nothing, so we'll return directly null. So if its left was there, we'll add left, we'll create a new node to its left, undo, and we'll move my iterator. Even if it was if not equals to, sorry, not null, it should be n. If it is not equals to n, that means there is some data. Okay. One thing, the value, node value is ranging, that I haven't handled. I have only handled for one value. I need to handle that part also. Okay, there's one thing that I missed. Maybe I'll explain. And what happens if there are values more than single digit, so like suppose 400, so there will be 400 over here with a separated comma, maybe 500, so we need to take this whole string. So I need to handle that part also. I haven't done that part. In that case, maybe I'll use two string just to convert this value into string and add it into my result. Now we'll take this node. Now if its left is present, we have to separate it by a single comma. So result plus is equal to result plus is equals to we'll convert it into string. First of all, we converted into to string. We'll add one more thing, result plus a comma separation. That means result plus whatever we'll add a comma and then this node value, and the same thing will be done over here. Instead of left we need a right, we need a comma. Correct. And if it is null, then also we need a comma. Or maybe I can do it together. Okay, I can. We'll see after printing the result. It's fine. I know it will throw a error because I haven't solved the DFS part. So the output is coming 1, 2, 3, null, null, 4, 5, null, 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 null. Correct. Output is correct. So I just have to handle this. So this part is working fine. Now I need to have something. Now my iterator will start after a comma. So I have to convert string to integer. So I have to take that portion off. So I need to pull a substring. Maybe data is equals to data dot sub str. Start from 0 index. Based on some delimiter I have to separate. There was some method, STL method, that pull a substring from a string based on delimiter in C++ STL. Start from 0 and s dot find delimiter. Token is caught. and my delimiter is this, so it will return me a string. Okay, I can use this, maybe this will help me. So I have data.substr. I'll start from 0 and data.find, and my delimiter is comma. So whatever string, no, I'll store it in some str and string to integer str. There is a method called string to integer. We'll start from str.size plus 1, because str will give me what, suppose there is two strings, so its size will be 2, 0, 1, 2, and then a comma will be there. I need to start after that. So this DFS, if data of IT is not equals to n, that means there is some data. So what we'll do, we'll again do the same thing, data dot sub str, and I'll start from this IT and find this delimiter. It will give me a, so I'll create a new node which will be a stoi string to integer this str, and now my IT will be IT is equals to IT plus str dot size plus 1. So it will go to the next value. If it is null, that means the current value is, so IT plus is equals to 2. So I'll add 2 in my IT. Now if data IT, again I'll check for write. The same thing, I'll do the same operation again, and now this time it will be node write. And DFS will be called on its node left. IT will go as it is, data will go as it is, and then DFS will be called, no, and data will go as it is. And finally we will return node. So what, run this and see what error can we face. This is my serialize. This is my deserialize, and this is my now if not node, I'll also return from here if it is not node. It should be automatically initialized with null, right? Okay, what is the problem that we are facing? Let me just print this. Result. So this is totally correct. Now pass the data as a pass by reference. So okay, what is happening? First, my iterator is at 2, 0, 1 and 2, index 2, and in node, in root, in node IT, and data it passed, it went over here. IT is 2, correct. So if not node, I'll return. If data of IT is not equals to n, I'm converting into integer, so 2 is added to its left. And then 2 is added to 3 is added to its right, and then we went for a left call. So we went for a left call. We saw that there is no node. So these pointers should move, right? These pointers should move. else it will not. Okay. Just simple mistake, very simple mistake. I think it. If node is not there, suppose if node is not there, I can do it simple it plus is equals to 2 and move forward. I moved it to its left to, there was null and null. This side will also be and I added it over here. Why I'm only getting this? Let me once dry run this. I think there is some small mistake that I am doing. There must be some small mistake in the DFS half. Okay. Let's just dry run for once and we'll see what is happening. So this is my node, my IT is over here. Now we checked if this is not null. What we are doing in DFS, if IT went beyond data.size, it is not. So if data of IT is not equals to n, it is there. So I'm picking a substring from here till I find a delimiter. So I'm creating a node left with a new tree node of stoi of str. Correct. So this is done, and I moved my iterator to here. So my iterator went over here. Now I checked the second that whether its right is should not be null. It is not null, so I picked this. I made a node of right, new node, and and I moved my iterator from here to here. So now my iterator is over here. Okay, and I called my node left. So I called my node left. So my node reached here. Correct. My node reached here. Now what I have to do, I checked again whether my IT reached beyond or not. So it did not reach beyond. So this is correct. If it is not equal to, it is null. So what I'll do, I'll simply increment my pointer to 2. So I incremented my pointer from here to here. Now still my and it is n. So I'll again increment my pointer from here to here. So my IT went here. Now I saw that node was the so this node is there. So even let's remove these two half. If it is there, else now I called its left. I found there is no node. I'll simply return back. I called its right. I found no node. I'll simply return back to 1. I called its right, which is 3. My iterator has not yet changed. So I came to 3. If not n. So I made a left. It's left to 4 and I moved my pointer. And it's right to 5 and I moved my pointer. Over here. My iterator moved here. Now it's left 4 is called. But it's n and n. Its left will be called, it will be null returned. Returned. Hey, why in dry run it is working? There is no node attached to its 4 and 5. Why we are not able to attach 4 and 5? This will not help. Mm-mm. Some something is missing. What is missing? My iterator is here. I have already made a one node. Now my iterator is not beyond data dot size. If data of it is not equals to, so I'll create a new node of its left with a value of 2, and I moved my pointer to here. If this data is still not equals to, so I'll make a right node of right as 3. I'll move my pointer here. Now my node is currently here, so I'll do a call to its left. So I went for left, so my node went here. If it is not equals to n, it data of it is equals to n. So I'll move my pointer plus 2. So my iterator will move over here. Now the next value is still n, so I'll add 2 again. So my pointer will move over here. Okay, I'll do a left call which will be null. There's no left, so I'll not do a left call. There's no right, I'll not do a right call also. I'll fall back. I have already created a right for this, so my node will jump over here, and I have 3. So iterator is not equals to n, so I'll do what this current node left, I'll create a new node with value 4, and my iterator will be here. I'll create again value with node value as 5. My iterator will move here. Now its left is present, so I'll go to its left. This is n, so I plus 2, I will move here. This is n, I plus 2, move here. Its left is not there, even right is not there, so I'll not go. I'll fall back here, and then I'll do a right call for this. Now again I plus 2. Hey, it's what mistake I am doing. Even the output that is printing is correct. Must be some silly mistake. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2. Initially my index is at 2, 3, 4, 5, 6, 8. 0, 1, 2, 3, 4. 8, 10, 8, 10. Oh. Oh my god. This is so bad. I did not pass it as a pass by reference because this iterator will never change. So when the recursion was going back, the iterator value was also changing. But that should not happen. Let's make it null and run it again. Fine. Okay. Let's try and submit it and see whether we were able to solve it or not. Okay, there is some runtime error. For some okay, let me see if negative values are converted by STOI or not. There is some problem with STOI. So the negative. Oh, I did not handle the negative. String. Let me print this result. What? -2, -3. Okay, I just need to check whether it is minus negative sign or not. If data of IT is equals to a negative sign, if it is a negative sign, boolean energy is equals to false, energy is equals to true, and IT plus plus. And negative is equals to 1, negative is -1. see if this will work or not. Okay, now the negative values are also being handled. This stoi string to integer never converts a negative value. Okay, let's use this test case and run. Std out. I'm even using this test case. But why we are getting a wrong answer? -4 -7 3 null null 397. Okay. Mm-hmm. Nine minus 7 minus 4 and 6 and minus 6 and n 065 and 9 and minus 1 minus 4 and minus 2. Okay, so the output, this string is correct. The one which I am converting is not correct. What we are converting, how we are converting. We saw 4, -7, -3. Now -7 has null null, -3 has -9, -3. Now -9 has -9 and -7. And 9 and -4 and null. The tree is forming something like this, is it? It will have negative 9. We'll have negative. We'll have 9. Uh, negative 3, negative 4. Oh my god, it's so simple. रूट का बस input string stream ss and data.
simply serializing means simple call I'm making, and while deserializing. So simple, huh? But what I was doing is so much complicated, but still I was not able to solve it because for the first tree, 1 minus 2 minus 3 6, its right is null, then 3, then 7. Actually, the problem, I know what the problem is. I made this string using a level order approach, and now I'm creating a string back using a DFS approach. I created a string using BFS approach, and I'm making a string tree back using a DFS approach. This will never be same, correct? If I made this string using a BFS approach, then make it back using a BFS approach only. I think that is where I am doing something wrong over here. Let's go back again and try and think over it. So this is null. 1, negative 2, negative 3, 6, n, then 3, then 7, then n, then n, then n, then n, then n, then n. So this is what our string is. So I know this is my 1. Its left and right is minus 2, minus 3. 1 is here. 1 popped. Its left and right is these two values. I pushed it. Okay, and also I made minus 2 and minus 3 as its left and right. My IT moved here. Now this is negative 2. Its left and right is 6n. So I'll make here 6 and right as null, and I'll move here. And also I'll push 6 over here. Now this is negative 3. Its left and right should be 3 and 7. 3 and 7. I'll push 3 and 7 again, and I'll move my pointer over here. This is 6. It's this this will do the job. I think this will all again do the job. I'm doing wrong because I'm using DFS. No, I should be, if I'm using BFS while creating a string, make a BFS while create while generating the tree. I did so wrong. Shouldn't have done that. I should have thought it before. Okay, I'll remember this part next time. So you have to do nothing. Remove this also. Let's try it again. I have a root which will be nothing but new tree node. And I have to pass a value. String str will be equal to data dot sub str, starting from index 0, data dot find comma delimiter. Now if str of 0 is equals to something negative, that means the value that is at the root is already negative, so I need to handle that part also. Str of I neg is equals to 1. IT plus plus. Let's start from IT. I'll start from IT and I'll find a comma separated. I'll find the story str multiplied by neg. Create a queue of tree node q dot push. I'll push this. So while not q dot empty, while queue is not empty, what I'll do, I'll take this node from top, so q dot front, q dot pop, I'll pop it from the queue. Now now it's, I have to look at its left and I have to look at its right, which will be uh, uh, and also it plus is equals to str dot size plus 1. Now if data of it is not equals to n, that means it's not null. If it is not null, that means there is some data. So neg is equals to 1. Now if data of it is equals to a negative value, then neg is equals to -1. So if data of it is equals to 1, so n is equals to 1, it will be increased. Now the same thing, data it comma separated, and this node left will be a new tree node with value stoi of this str1 multiplied by n. Now my iterator will increase. Else it plus is equals to 2. This was for left, and very much similar thing will be for right also. Node dot right else. Now if node left is there, then q dot push node left. If right is there, then q dot push node right. And at last, line 46. Oh, okay. Do I need this? I don't need this. Okay, so if I'm doing with BFS, I have to do with BFS. Correct. That is one thing that I'll take from here. That if I'm doing a DFS traversal and I want to make it back to tree, then we still have to do a DFS traversal only, because the DFS traversal and BFS traversal are different things. So hopefully this time it should accept my submission. Let's see. Okay. If the first node is negative, I handled that part also. If data of 0 is negative, and IT increased. From IT I found hey, why? Where it broke. It did not even reach here. Are you sure? Don't call this return null. So in case for my standard output is negative 101 and this is coming correct, means why. Okay. So if data of 0 is equals to negative 1, I made this as negative 1. I did handle this. Oh. Means Toy is doing something else. this is negative n. It's minus sign. I increased my IT from IT comma separated. I found this. Why? Oh, comma is also coming. Means data dot substr it data dot find comma, but I don't want to include this comma. Do, but why? Str dot pop. But why not for the rest? Why only for this? Why only for this it gave me. It's still 2 comma. Now it is not throwing any error. Now this time if I remove this, it will work. No. really, this STOI always do some or other, creates a problem. I shouldn't have done this beforehand only. What? There's no problem over here. The first time. mm, what we got is a comma also. So I removed this comma from 0 plus 1. 0 plus str dot size is 1. So it went to 1th index and I added one more to it. So it went to the next index. Where did I call this toy before even printing this? This should be printed. Then only I called this toy. When I printed result, it did not. First time it printed 1 comma. Should have only printed 1.
I'm using this delimiter, so it should not print this comma. Why? Why it printed comma? 0 1 2 3 4. It directly jumped to 4. Nice. Zero, 1, 2, 3. Which gave me 2 comma. Why it is printing 1 comma 2 comma? I only want 1. Is it even a working? See token. So in this token only Scott printed. This printed only Scott. And if I start from index 1, oh, this is something else. OTT greater than equal to. What is this? And if there are multiple okay, this I want to find a string substring from a
specific index till I find a delimiter in and the position of the delimiter starting from so this thing is something wrong. So it will be data dot substr from this position is IT, and the last position is data dot find, what did it say, delimiter and start index. So my delimiter is a comma and my start index is IT. So it will give me the position of that index. So minus IT, that index minus IT will give me the length. Now I need that length. So this so I got 1. So this is what I was doing mistake. I have to do something like this instead of all these. Let's try and see. STR. Okay. Still why this toy, this substring getting added? That's why we should use those s string stream and all those things in order to handle these parts. So we have this string printed. Okay, this is what should be str1 dot size, not str dot size. Still, if stoi will give me something. Oh, finally. Okay, this is really irritating. I shouldn't have picked at first. This stoi, string to integer, is really bad thing to use in any case. Don't ever try to use this stoi if you are struggling with indices or something. You need to fix your indices thing first, and then only if you are 100% sure that it will give you integer value, then only you should jump to stoi. Because what I can see in my previous submission, I used dfs over there. This time I was using bfs. So earlier I used a string stream, I string stream, which will give me directly all the values using a delimiter. I delimiter was a space, single space. So I created a string using DFS approach. This is what I used. I simply used a DFS approach, and I generated a string. And while deserializing, I again used the DFS approach directly. I extracted every string from SS. I made I string stream SS, and I added this data as an input of to SS. So it will separate each and every words using a space delimiter. So I'm extracting this and adding it into my str, and if my str is null, I'll simply return null. Else I'll create a new node with this str and call this new nodes left and right. This was really easy. Shouldn't have gone for BFS at first. But one thing that I got to know, if you are using BFS, then use BFS only for serializing and deserializing both. If you are using DFS, use DFS only for serializing and deserializing both. Should not mix serializing and deserializing with BFS DFS or DFS BFS. It will always give you a wrong answer. Okay, great. So something new I learned today. Actually, this was a common sense, but still I have some kind of less common sense, maybe. No issues. I learned a new thing. I'll take a 10 minutes of break, and after that, when I'll come back, I'll start again. I'm back. Let's okay. Let's solve few more question. I haven't submitted this question in this part. The serialization part was okay. Um, I suppose it was fine. The only thing was BFS, whole BFS code. Okay, it's accepted. Let's submit here also. And then we can jump to binary tree maximum path sum. Accepted. Great. Some so we learned actually few good things in this question also. So if you want, you can try this question by yourself and see if you are facing any issue or okay. Let's get to the next question. Okay. Binary maximum path sum. Let me see if it is present in lead code or not. Binary tree. So, okay, let's read the question and see what the question is saying. So the question says a path in a binary tree is a sequence of nodes where each pair of adjacent node is in the sequence has an edge connecting them. Cool. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. The path sum of a path is the sum of the node's value in the path. Given the root of the binary tree, return the maximum path sum of any non-empty path. There is few more examples over here which is I think better. That returns the maximum sum. A path can be defined as a sequence of nodes between any two nodes and doesn't necessarily pass through the root. Sum is 42136. Okay, we are not including this path because we have been so the value node's value can be negative also, correct? Okay. So there is two thing that I can see over here.
if I'm going left, it's right, we are reaching to null. uh, okay, from here if I return the value present at the leaf node, and from here we return the value present at the leaf node. Let me just maximize this, just a second. Okay, better. So from here we are returning 7, from here we are returning 8. Okay, now here there will be two case, possibly one case number 1 and case number 2. Case number 1 is if I sum this plus this plus this, there might be possible that this left is the largest. Out of 3, whichever will be largest will become my answer, and I have to return something from here also to the previous node, saying that which path to lead to. So if I'm returning from here, suppose if I'm returning from here, okay, let's suppose the first case, whether if this subtree is giving me maximum answer or not. How will check whether this subtree is giving me maximum answer or not? So it might be possible the value which is coming from left is giving me a maximum answer. It might be possible the value which is coming from right is giving me the maximum subtree, or the one more possible that the value, if I'm considering this as a part of that subtree. So if I'm considering this, then it will be left plus node plus right. Correct. So out of these 3, whichever is maximum will be stored in my result somewhere. Now I have to return something from here. If I'm returning something from here, it might be possible that it will be somewhat this path, or it will be somewhat this path. We cannot combine both paths. We have to segregate only one path. So whosoever will be maximum will be returned from here. So if left plus the node or right plus the node, in both whoever will be maximum will be returned to the previous node. So suppose 8 plus 5 is 13. 13 will be returned over here. Now from here 9 is returned. From here 9 plus 6, 15 is returned. So 15. From here 1 is returned. From here 3 is returned. And from here 3 to 5. 5 will be returned over here. From here 15 will be returned. Now 13 plus 15 is what I would say 28, but 15 plus 5 is only 20. So 28 is maximum, which will be, we will be storing it in our answer. So I think these are the two cases more than enough to handle our maximum sum, the path with maximum sum. Will there be any problem in this?
Output is 31. Eight five three six nine. Oh, okay. Plus 3 also. Whosoever plus 3. 28 plus 3. That is 31. 15 plus 5, that is 20, plus 1 for this 21. So 31 is the maximum that we are getting from here. So I think this should do the job. Maybe let's write the code and see if give me a minute. Give me a minute. Okay, fine. So we'll be returning, we'll be calling a solve, and let's suppose we take a global variable as result, which will be integer minimum, because the values are ranging from negative to positive, right? So I'll return result. I'll call this root. So integer solve. Now if not root, I'll simply return 0. I have to start from backtracking, so I will do all the root calls, all the calls first, and then I'll do the backtracking. Root left. Now whatever value will be coming from left and from right, we have to handle that part. Now there were two cases that we had checked. Possible result will be result will store maximum of left or right, or left plus root का val plus right. It will be maximum of all these three, and we will be returning from here maximum of left plus root का val, comma right plus root का val. Whosoever will be maximum will be returned. Okay. check here also. Whether I'm missing any case or not. Shit. Mm-hmm. Case 2. It's coming out to be 35. When the expected case is 40. It went returned 0. So left plus root ka value is 15, right plus root ka value is 15. It will return 15 over here in its left. Its right, it will return 7. So left is 15 plus 20. 20 plus is 35 and plus 7. Okay. Is there some problem over here? Should I separate both? It is coming out to be 35. Uh-uh. Oh, okay. I forgot something. I'm always maximizing, but result has some maximum value already kept over there, so I did not do that part. Maximum of these, and again maximum of result, comma rest of the things. $625.0. Oh, okay. Expected is -1. Test case -1 -3. Hmm. I was expecting this might fail. If I'm returning 0, if I return int minimum, if if this is the leaf node, okay. The only thing that I need to handle is from back. If I'm returning 0, that will give me uh, a maximum answer. Instead of doing all these, this will also not create a problem. Oh. So let's change it. I need to handle few edge cases. Edge cases is what if all the values are negative. Then in that case, if root is, then if I'm returning integer minimum, the subtree can be a smaller part also. It cannot be. There's one more thing that I forgot. Left val or right val. Alone left, alone right. Left plus right. Or is alone val also. If left plus val, right plus val, or alone left or alone right, will also be one of the possible case. If I add a test case, the value is ranging 1000, negative 1000 to 1000. No, I don't have to return left or right. I have to return root ka value. Either this value plus this value plus this, or only this. रूट का वैल मीन्स सिर्फ वैल. So it will handle the negative part also. Okay, I need to make it long. Throw error. -625 -1. Okay, let's see. What? If the test case is 1 2, result or left or right or left plus val plus right or single this val or left plus val or right plus val. Why this came to be? Give me wrong for the fourth. So int max result is either result which is int min. I am finding maximum. So int min result or whatever from left, whatever from right, or this plus this plus this, or only this. So return 2 back to int min. Left plus val. This is what I added. previous case also. Okay, great. So the only thing that I needed to handle is these extra maximums, whatever the maximum and what needs to be returned. Let's submit it here also and see. Accepted. Great. So the maximum that I need to handle is result, left, right, either whatever the value which is coming from left or whatever the value which is coming from right. Out of them, if anyone is maximum, or the value which with left plus root value plus right value, whether that is maximum, or the value which is exactly there. What? Why? Okay. Or the value which is exactly there, that is maximum, or left plus value is maximum, or right plus value is maximum. Whosoever will be maximum will be stored in my result, and I'll return what if that value specifically is maximum, or left plus value, or right plus value. If any of them will be maximum, will be returned. So this is how we'll be solving this question. Maybe I'll just share this link also. You can try by yourself and see whether you are able to solve it or not. Okay, so serialize, deserialize binary tree done, binary tree maximum path sum done. We already solved this in the last stream. Merge case sorted list already, find median of data stream already. A word search 2 we haven't solved yet. Alien dictionary needs to be already solved. We solved this. This was a topological sort. If you don't remember this, or if you don't know how to attempt this, you can go to my just previous stream and you can check there. I have already solved this alien dictionary, so it was quite interesting question. So the only hard problem left over here which I haven't solved is word search 2. Let's try this out. So I'll just share the link. You can also try by yourself if you are able to solve it or not. Okay, so let's see. So we are given a m cross n grid of characters board. Board and a string word. Return true if the word exists. In the grid, the word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. So the given input word is A, B, C, C, E, D.
So I need to check whether the word ABCCED is present in this or not, or and the constraints that are that I can only go to the adjacent cells. So if I see A B C E, so from A I need to go to B. So from A I can go to B because it's adjacent. From B I need to go to C. I can go to C. From C I have to go to C again. So I can see there's no C on the right. There's no C on the left. Left we cannot go. So C I can see we can go to C here. Now E I can go to E again. Now D, from here I can go to D again. So all in all I can see A B C C E D. I can go to each and every string from here. So the word exists in the board. Now for the second part, SEE. Let's see where is my SEE is there. Is there any word, any letter starting from S? Yes, I can see this. Now can I go to E from here? No, there is no E adjacent to this, so I cannot go to E. Let's search for E again. S, I found S. Can I go to E? Yes, I can go to E. Can I go to another E from here? Yes, I can go to another E. So for this also the output is true. From S I can go to E, from E I can go to another E. So for this also, sorry. So let's see if any word, any example is there where we are returning false. Uh, just a second. It's saying word search 2, but this is word search 1. Yes, it is returning only true and false. Output is true or false. So now this is word search 2 exactly. So given an m cross n board of characters and a list of string words, return all words on the board. Each word must तू और शिवम का मेरे लिए क्यों कर रही, मैंने बोला थोड़ी था. अभी नहीं. Each word must be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. So what I okay, there are lots of words. There's not a single word. I need to check whether oath is present or not. So OATH. Oh yes, oath is present. P is present or not in this? So P is not present. Where eat is present. Eat is eat present. EAT. Yes, eat is present. So I have in my answer eat also. Whether rain is present or not. Or yeah, no, rain is not present in this. So I have to return eat and oath. Okay, they are present. So it's very much similar to word, word search 1, where I'll find a word, I'll iterate over the 2D grid and check whether the whole word is present or not. But uh, here is something that I need. This words of I consist of lowercase English letters. All the string of words are unique. All the strings of word are unique. What's the time complexity if I go one by one and search it in my 2D grid? M cross n is 12. Board of ij is a lowercase English letter. Word dot length. Words dot length. There will be total of 10 to the power 4. And each each word will have a length of 10. That means 10 into 3 into 10 to the power 4 and 12 M cross n grid. Can we this one thing that is coming in my mind is pick every word, do a recursion call, search for that word, whether it is present or not. If it is present, return true. If it is not present, return false. That is one thing that is coming in my mind, but this might go TLE. Can we try something with the help of try? Try. Can we use try over here? Can we use try? Try. OATH. Have OAT and H. I have PEA. I have EAT. I have RAIN.
Now I'll iterate over this grid. I found this O. Mm-mm. How we can reduce the time complexity a little more? O, there is something starting from O in my answer. There's something starting from uh, P in my answer, but there's no P over here. There's something that is starting from E and something is starting from R. O, O, E, R. O, I have O, I have E, I have R. How can we approach this? If anyone watching this stream, please do comment anything. Let me know that you are also trying to solve this question. I'm trying to think whether a try solution is possible or not. Whether this try solution is possible or not. OER. Can we do something with the help of try? We went O. The next is A. We have A. The next is A again. We don't have A here. Then might be possible that OA एक A भी हो यहाँ से OAAN and OATH both. Okay. I don't know if I'll be able to solve it using try or not. Let's think over it. Let's take a 10 minutes of break. After this break, I'll try to see if it is possible or not, or else we'll go for some other approach. Okay. I'll be back in 10 minutes. So see ya in 10 minutes. Okay, so we are back. Okay, word search 2. So, actually, I was thinking of some try, maybe something related to try is there. Okay, I can think of try approach also, but how? Mm-hmm. Will try reduce the time complexity? Is try going to reduce the time complexity? Is it possible? Okay, let's go for one. We have O. We found an O. Now, if I move this pointer, I iterated to the next one. I have O A. Anyone starting from A? No. There is one at A. Uh, but this is my pointer went to here. I have A again. No A is there. I have N. This M cross N is 12. It can go maximum of 12 cross 12. So, is it possible to make all the substring uh, from this O A O A A O A T H? But how? But the problem is how. If I'm making a try for answer, that is not going to help me very much. Even if I'm making this is in my try, that will also not, or even if it is helping me, how? Even if it is helping me, then how? Is the editorial available? No. Directly use try implemented. Python. Simple and clean Java code using DFS and try. Try implemented. based on implemented try in lead code. Try node, try solution are treated as separated classes. hmm Let me filter this based on most recent. Simple solution try plus DFS. Using try easy to understand. Let's see. Okay. To solve the problem of finding all words from a given list, there are present in a list that are present in a 2D board of characters. We can use a try data structure to store all the words for efficient prefix searching. We then perform a DFS on each cell of the board to find all valid words. We then perform a depth first search on each cell of the board to avoid all valid to find all valid words. The try allows us to quickly search if a sequence of characters forms a valid word or prefix. Initialize the try with the given word, iterates through each cell in the board, and perform a DFS to find all valid words. Sitting. So this is my DFS part. Let's. This is a class of try node. That's fine. I can create this. That's not an issue. This is my try initialization. I initialized our try. Now this is inserting our word to try. Fine. This is also not a big problem. Find a word. I have words. I have a try root. Insert set string answer, taking set because we may encounter duplicates. Okay, do we have to return unique? The same letter cell may not be used more than once in a word. uh-huh. Board, this is for visited. I just did a direct DFS, and DFS I need to check. I passed my root for this specific I and J indices. I passed board, I passed visited, I passed my try dot root. Okay, try dot root IJ. This is nothing but a string creation string maybe, and this is my answer. And finally I'm converting it into vector and returning it. That's fine.
So we have these as boundary cases, doesn't matter. I've picked a character, calculating the index. If that word is not present, I'll simply return. Else my node is equals to node ka child, and this is what my current word is forming. Current word, add it to the current word. If node का is end अगर true है, that means we found a word. So result dot insert current word. Result. Okay, this set is my result now. So for every index we are doing our DFS. It might be possible some other place also we find the same string. But will that reduce even the time complexity? It's fine that using try we can do it. Let's try. Let's see. So we have try class tri. This is my class try. This will have two things. Can I make it private? Should make it private. It's public, so that this can be accessed from outside also. Okay. So there will a vector of int of its children, which will be of size 26. This will be try pointer, initialized as null, or maybe do not initialize it. Int is end. Let's make a try constructor. Children dot resize, size 26, initialized. Null is end is equals to. This is my try data structure. Now
try node. Root is equals to new try node. Pass nothing. Now there will be a method insert into try. So it will return nothing. This will be simply insert where we will get a string word, and I'll have to create a tree node iterator which will point to root initially and when I is equals to 0, while I is let's try for each char ch. ch minus a. If it का children of val, if it is not there means it's null, then we'll create a new. So it of children का val is equals to new try node. And it is equals to it का children of val, and at last it isn't is equals to true, that this is the end. Now I'll iterate over each word and call insert method with words of I. This will insert. Now I need to create an answer. Set string result and at last I need to return result. What was this? Vector string. I can directly parse into vector string result dot comma result dot and now I'll iterate over each of the word and I is equals to 0. plus j, and for each we'll do a DFS call where I'll pass. I already have a global root, so I don't have to pass root. what I need to pass is board, a string which will be empty, which will create an answer, this result, and after board I need to pass ij, these two indices. So this was the insert method. Let's do the void dfs method, where we will have this board, correct, int I comma int j are two values. Board is of character type. Board is our character type. I don't need visited. I can use board only for visited part. String formed word, till now whatever the word is formed is stored over in this, and then this is my set. Percent result. Now my if base cases, if I goes beyond or equal to bow dot size, or j goes beyond or equal to board of 0 dot size something. If I went beyond, if j went beyond, or if board of I j is equals to 1, that means already visited. If these all the case, I'll return. Now one more case, if okay, I need to pass root also from here. Root after ij, I need to accept this try node. Now if node of children board of ij minus a, if that word is not present, return. Else char ch is equals to visited is equals to board of ij, and now board of I j will be simply 1. Now if it is not, then I'll directly move node if there is only single word like O, and the is true will be true. Formed word plus is equals to board of ij. Now if node of isn't is true, so result dot insert there will be 4 calls I plus 1 j node of children of board. No, it will be visited. I've already changed it. Visited. Visited of I'll jump to that node. I j node formed word will be as it is, result will go as it is. Char I plus 1 I minus 1 j plus 1 j minus 1. Now board of ij will be updated with visited, no, its original character. And also pass it. See what all errors are there. Let's resolve the error. Try 9. Oh, अच्छा. Nothing.
Hmm. See, this is. I have to move my node is equals to the next node, and only node will be passed, because once I found that character I don't have to recurse back and create a new character. I'll go to that. Only oath came. Why not eat? This will remove oath also. Yes. But it oath is coming. Why not eat? Uh, Why only oath is coming? After oath, what happened? Uh, mm, mm, mm. This time, eat and oath both are coming. But in but why? But why? Why eat is not coming in my answer? Formed word. Only oath, not eat. और change किए तो eat आ गया. Means if I only place, if I remove this oath, what will happen? Because of this P, something is happening. Because of this P. Eat. If I. What this P is doing? What? But why it is creating a problem? Shouldn't know. Oh, okay. Now I understood. Why? Because of this visited. It is converting it into one. That is what I don't want. Means this board, this word, this board is being converted again and again.
this board will. After all these calls, what is happening with board? Is there something wrong happening with board that I'm not able to figure out? See out. Okay. Great, 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 great. Board, board. Totally my bad. See if I'm able to submit it or not. Whether it is. It's giving me wrong. Output eat is there. HF is there. Oth is. So I have to return it in order. My output is. The answer is correct. The answer is correct. But the first is oath, then comes eat, then comes HLF, then HF. So in that case, I'll keep a set or even unordered set result. No, let it be as it is. If result dot find words of I is not equal to result dot end answer dot pushback. Eh. Oath eat h HLFK. अभी तो आया था. Oath eat HKLF. Where did it go? Where did it go? इस बार तो सही कर रहे हैं ना हम वर्ड्स. अरे अभी इससे पहले ये कोड में हम ऐसा क्या कुछ किए थे क्या? ऊपर पे कोई चेंजेस? नहीं. रीसेट करो इस कोड को, इस टेस्ट केस पे रन कराओ. अभी तो आ रहा है. तो ये चीज़ जब हम आंसर में कर रहे थे तो क्यों नहीं आ रहा? If result dot find words of I is not equals to result dot end, that means it's there. So answer dot pushback. So instead of sending this, send answer. Huh. Great. Why this HKLF is not coming? जबकि रिजल्ट में है, सेट ऑफ रिजल्ट में है वो. Auto IT is equals to, I'll just show you result dot begin while IT is not equals to result dot end, cout asterisk IT plus plus. देखो EAT है या
for last EAT, HF, HFK, LF, ओथ सभी हैं, 4 हैं. पर जब मेरा आंसर बन रहा, जब हम आंसर बना रहे तो 3 ही आ रहा. बट HFK, LF आ रहा और यहाँ पे HKLF है. ओह, तब तो सही था. इस कोड को रिट्रीव बैक करो. फाउंड वर्ड डॉट पॉप. Okay, it's accepted. If I am going back from here, there's one thing that I'm just a little confused about, this formed word and this node. Just a second. I found this O. I made a word of O. I found this A. I checked A is there. I went to A. I find a T. This is HKLF. H LF. Now from H we went to F. Oh, it is because I'm passing by address. So HF is always HF, but I'm creating new here, creating new answer over here. This then also the answer was HFK LF, means HF पे पहले गया. From H it went to F. Okay, so my answer became H and F. My recursion fallback from F. From H there is a K. From H there is a K. From H there is a F. This at the same. So from here, from H, I I called a recursion for F. There was a F, so I added this H in my formed answer. From H, I can also go for to A. That means this node is also recursing back. This pointer is recursing back, but this formed word was not recursing back. This was global. This node is inside the recursion. Okay, that is the reason this was happening. Got it, got it, got it. Okay, so finally we were able to solve this word search too. It was quite nice to solve it using try. Try is not that difficult if you want to try solve using try. It's really, it will help you a lot. Tries will help you a lot in solving your questions. So it's good. It's really good. Okay, so I think I'll take a break now, a lunch break. I'm really feeling hungry. It's almost 2 o'clock. So I'll take a long break, 60 minutes, and because I have to order food, I haven't ordered food yet. So after the break, I'll be back, and then we can do some more coding, some more hard level questions. We have already solved all the blind. I think any else left? Word search 2 solved. Alien dictionary solved. Solved. All the hard level questions were solved. Okay. So let's take a break, and after the break, I'll be back and we'll solve more questions. I'll pick from lead code directly hard level questions, and we'll solve it. Okay. See you after lunch break.
Hello everyone, I'm back. Okay, I've eaten a lot, so I think I'm ready to. Okay, okay. So I think we solved this word search and word search too. Maybe we can even solve this word search using word search 2 approach, which is uh, this. The only thing that I had to do is like earlier in word search 2 we have multiple words to be searched in the grid, but in word search 1 we only have one word to be searched in the grid. So the approach will be exactly same, nothing to change, and directly we can find, and we can even return true or false. In that case we have to return true or false, so we can simply return true and false. Okay, now we'll try to solve few more questions. was thinking of was thinking of picking some hard level question, and obviously it will be. Okay, so which one should I go for? mm, Number of atoms, sort item by groups, respecting dependencies. Obviously, maybe we can go for number of atoms. Let's try this number of atoms. Okay, so the question says, let's find what the question is saying. Hmm. But why can't I type? Okay, so it is saying that we are given a string formula representing a chemical formula. Return the count of each atom.
Okay, we are given a chemical formula. We need to return the count of each atom. That means H2O means hydrogen is 2 and oxygen is 1. MgOH2. So hydrogen is 2, Mg is 1, and O is 2 because it's in bracket. So MgOH2. Just a second, give me a second. So okay, let's take this as an example. K4 ON SO3 whole 2 whole 2. Okay, so it is saying SO3 oxygen is 3. Already I have oxygen as 3. So bracket is opened, bracket closed. So the value after bracket closing, I need to take that value. I need to multiply it till my bracket becomes empty, open. So let's solve the bracket part. Let's solve one bracket and then we'll go for the second bracket. SO3 whole 2. So we already know oxygen is 3. S is 1. Now after this bracket I found I have to go finding values, finding numbers. So I'll try to find numbers as much as possible, all the numbers, and then I'll pop this bracket, and whatever value this O will have, I will multiply it with 2. So O will have suppose 6. Now S has a value of 1, so multiplied by 2 will have 2. Okay, now this says one multiplied by 2, that is 2. Now this says that now S is 2, O is 6. After that we have a bracket ON. So this will be multiplied by this.
Now this whole value is multiplied by 2. After this value is multiplied by 2, then this value is again multiplied by 2. So if we are solving the smaller part, it will create a problem. Let's try from bigger part and go to smaller. The biggest bracket that we have, can we try from that position? So let's solve from bigger bracket. If we open this bigger bracket, we'll have a number. So this number is multiplied by 4. So SO3, outside it's 4, it's ON. But oxygen is only 14, right? This 4 is for this. This 2 is for this. S is equals to 4, O is equals to 12, and again O is equals to 2, N is equals to 2. So O 12 plus 2, 2 plus 12, that is 14, and K is 4. Okay. It is confusing a little bit. Can we go for this? Should we start with the bigger bracket or the smaller bracket? I think the smaller bracket will be much more easier. So suppose we have S. S is an individual bigger number. See, always if there is an element which is combination of two or more letters, then it will always be in the form of first letter capital and the other letter will be small. So I'll have to find all those things, and so suppose NA is there, so N will be capital, A will be small. So let's go one by one. Let's solve this K4 ON 2. Let's solve this ON. So ON is, we had a opening bracket. So in my stack I added open bracket, correct? Now I have a character O, then I have a N, and right now I'm not taking the two letters. Let's start with smaller and see what will happen.
Now we have a closing bracket. Now it might be possible after this there is no integer value, but I need to search if there is a integer value after that or not. So I need to find all the integer value after this. So somehow we are able to find this integer value. So I'll pop this n, and I'll say okay, whatever the value n had, now it is 2. Now I'll pop this o also, and multiply it with 2. Now I need to push it back. Don't you think so? I need to push it back again. Okay. I'm getting something. Let's see. Let's see again. On 2. We have an opening bracket. We opened a bracket. We have o. We'll keep o as 1. We have n. After n there is no integer value, so we'll make n as 1 also. N as 1. We have a closing bracket. We closed a bracket, and then we found an integer. So if it is integer and the last was a closing bracket, that means this whole will be multiplied. Correct. This whole thing will be multiplied. Now I removed this closing bracket. I popped this n. Let's keep it in some separate n, and whatever integer value I'll multiply it with that. I'll pop this o. Whatever the integral value, I'll multiply it with that, and I saw an opening bracket. So if I make a closing bracket, then a o. Their work is finished, so their opening bracket should also be removed. So I'll remove this opening bracket and I'll push, but I have to push the elements back. So o and n will be pushed back. This bracket will also be removed. Now suppose there was on. Now SO3 with 2. Now how to handle this? Let's see. We encountered an opening bracket. I'll push an opening bracket. We found an S. We pushed an S. We found an O. We pushed an O. Now we found an integer. But the last element that I pushed was not a closing bracket. That means I don't have to iterate. I just have to check the last element O S in my map 1. I'll multiply it with 3. I will multiply it with 3.
Just a second. Okay, I'll multiply it with 3, and after multiplying it with 3, my answer is 3. Okay, then we found a closing bracket. Then we added a closing bracket. We encountered an integer again. And with the last is my closing bracket. So that means I have to multiply everything that until and unless I find a opening bracket. So I'll keep a new stack. I'll pop this until and unless I find an what should I say, opening bracket. I'll pop elements. So I'll pop this O, whatever the value this O contains, I'll multiply it with 2, so it will be 6. I'll push it in my here. I pop this as, I push it here, whatever value as contained I multiplied with 2, so 2. So right now my O is 6, S is 2. Okay, now we found for this also. Now let's try multiple brackets. Now ON 2 again. Now what I will do, I'll pop this out and push it again in our queue, in our stack. Everything is now empty from here. Now again, what will happen now? Let's start from start and see is something that we are missing and how to handle that part. If we are able to handle that part also, then we are good to go. Now we have an O. Okay, we pushed O, kept O as 1. We have an N, we pushed N, we kept N as 1. Okay, initially I had an opening bracket, so remember to always push opening bracket. Now we have again an opening bracket. Until and unless we find a closing bracket or an integer, we won't be doing anything. So we found an S, so we'll push S with 1. We find an O, we'll push O with 1. We found an integer. We already saw that we had an O. We again came to O. It's so maybe instead of keeping it in map, I'll just keep it in here only. So let's try 1. We have 1. This is opening bracket. We have 1. We have O as 1 for now. We encountered an integer value 3. We'll check the top if it is whether it is a closing bracket. No, it's not a closing bracket. So whatever value it contains, I'll multiply it with 3 and I'll move forward, because that is the only element that is possible. Now there is a closing bracket. We pushed closing bracket. Now we saw a 2 value, integer value. So we saw a 2. Top is a closing bracket. So now what we'll do, until and unless we find an opening bracket, we will pop the elements from there. So we'll pop this out. O has value 3. So I'll multiply 2 with this and push it in somewhere else. O with 6. Now I'll pop this S again
s with value only 1, so I'll multiply it with 2, and I found a opening bracket. Fine. So opening bracket is also popped. Now what I will do, I'll repush these values again. So s with 2, o with 6. Now we found a closing bracket again. Great. Now we found an integer. Again we found an integer, and the top of the element is a closing bracket. That means until unless we find an opening bracket, will go. So we found a closing bracket, we found an opening bracket 6. The value was integer value was 2. So 6 multiplied by 2, so O will be inserted with a value of 12. O will be popped from here. Now S will be popped, S will be inserted with a value of 4. Now N will be popped, N will be inserted with a value of 2. O will be popped, O will be inserted with a value of 2, and a opening bracket. We found an opening bracket. Great. Now we'll push them back again. O with 2, N with 2, S with 4, O with 12. Okay, now everything is finished. So whatever I will do, I'll just O is 12, S is 4, N is 2. We again came O. I'll add over here 14. So in sorted order, I J K L M N O P Q R S. So it's in sorted order. So this is how we will be approaching this question. Uh, so let's try and let's code it out. So we will stack will contain a stack which will contain type string and an integer. st temp stack will be there. Now I'll start with 0. Where is this? I is 0. If I find a smaller number, means the case is smaller. Is upper, is lower. There are two methods that I remember. Is upper and is lower in C++ to check. It returns true or false. Correct. So if there is one more thing that is digit. C plus plus is digit. But we'll check that character is digit or not. Fine. So I'll be using is upper, is lower, is digit, all things over here. So if the current is upper, if there is a word letter which is upper letter, uppercase letter, so is upper. Formula of I. वो upper है और see whether it is a bracket or a upper letter, I'll push it. The only things that I need to handle is if it is a lower. So if is lower, then we need to do something else. If is digit, if that is a digit, then we need to do something, right? If it is a digit, if it is a or else I'll simply push it in my queue. The only thing left is digit and lower left removed, so upper left or and opening bracket and closing bracket left. So if any three of them occurs, I'll simply push it in my stack. So st dot push st dot push that value formula of I with 1. Let's keep the opening bracket and closing bracket also as 1. No issues. If it is a lower value, that means it will be multiplied with the value at the stack top. So string st dot top, I picked that string. Now str plus is equals to formula of I, st dot pop and st dot push this new str with the value as 1. It will be 1 only. Digits. Okay, if it was a lower case, we handled that part. Now if it is a digit, now we have to do something. It might be possible that there are more digits after this, so I have to handle all those.
So int val is equals to stoi. I'm again using stoi, but let's see if is lower formula of I, if is digit formula of I. So stoi convert it into convert this formula of I into integral. Now int it will be equals to, will start from I plus 1. Let it start from I only. Let's not do this. 1 while it is lesser than formula dot size, साथ ही साथ is digit formula of it. If these are the cases, I will be is equals to val into stoi of formula of it. Instead of 4, let's take it so that I'll have a control. So I extracted the value from here. I moved my the pointer to I. Now there will be two cases. If stack top is not a closing bracket, if st dot top is not equals to a closing bracket, st dot top ka first, I forgot this, st dot top ka first, if st dot top ka first is not a closing bracket, then come here, else go here. If it is not a closing bracket, then what to do? Just simply its number, its value, its second will be, so st dot top second is equals to st dot top dot second multiplied by val. Simple. Else else we need to do something in bigger logic. I'll be doing something. So if it is a closing bracket, I will be doing something. What should I call it? Calculate atoms, atoms. Calculate atoms. In this I'll send my stack. I'll send my val, both. And it will do the task. This one now can make it common as I plus plus. Now I have to solve this. Calculate atoms. It is taking this as its input and integer val that I need to handle. Now what this function will do, this will create another stack of same thing, create another stack of same thing named as temporary. So I know that the top element contains a closing bracket. So first of all I have to pop st dot pop. So that top is popped. Now while st dot top ka first is not equals to opening bracket, until and unless we do not find it as a opening bracket, we will move. We'll do what? We'll pop the top element. We'll take out the top element. So int new val is equals to st dot top का second multiplied by val. Correct. Now string str is equals to st dot top का first. Now st dot pop. I'll pop this element. Now this new value and this string str, these are the two things that I have. This will be pushed in my temporary. Temp dot push str with new val. This will be pushed in my new val. Correct. Stack is popped. Now after this I need to st dot
pop again once because that is opening bracket. I have to remove it. Now I need to push everything from temp back to stack. So while temp is not empty, st dot push temp dot top first comma temp dot top second and temp dot pop. This will return a thing. It will be void. I calculated atoms and my iterator incremented. Now what I need to do, well, not st dot empty, I'll create a map of string comma integer answer of st dot top first plus is equals to st dot top second st dot pop. I have to make a result. Auto it is equals to st dot no not st answer dot begin result plus is equals to it first and result plus is equals to I need to convert it into string to underscore string. Finally I will return my result. Okay, let's see. Okay, the first mistake is obviously it should be in double quotes. Because we are calculating string. See, don't do that. At line 46. Okay. Okay, there is something. Let's dry run with H2O. Dry run will help me find out what is the problem. So the first thing is H2O. I started from 0. Is lower? No. Is digit? No. This is no. So it will go in else. It will push H with 1 in our stack. Correct. So H with 1 is pushed. Now my I is plus plus. I went to 2. Is lower? No. Is digit? Yes. So value is 1. Now IT is starts from 0, 1. While IT is lesser than formula dot size and is digit formula IT. Formula of IT is also is digit, correct. So val is equals to value into formula IT minus 0 will give me 2. This will give me 2. 2 multiplied by 1 will give me 2, which will be stored over here. So the IT will go over here. IT will check digit. No, it's not a digit. So I will be updated with IT minus 1, which was the last digit. So val will should have had 2. Now if st dot top का first is not equals to a closing bracket, if it is not, then st dot top का second is equals to st dot top का second into so h will be multiplied by 2. Now I plus plus, I will go here. O is not lower, it will go here. So O with value 1 and then I plus plus. So it should have returned H2O. Let's see with what all values. First time H comes. It will go here. C out P plus plus. Check what's see, it's coming out to be 2. It's correct. Okay. Should I string str is equals to it?
result is equals to result plus it. If it the second is greater than 1, else don't add anything. (72 to 79). And in okay, conversion is being hell of a task. Let me see what wrong. What is the thing that I'm doing wrong over here? String str is equals to formula of I cout str. It is being converted into number 72, 79. So let's take this value as character. Now then convert it into a string. Finally, these conversions are really bad. Now let me test with H20O. Expected 20. Correct. Expected as 20. Oh, it should have been. Why? Why? My value, bro. Oh, come on. Into 10 plus. A silly mistake. I don't even know how to multiply. Is it? Oh god. Let's try with 25. Okay, let's submit and see if everything is correct or not, or if we are getting some wrong answer. Okay. Okay, there are even but I have a opening and closing bracket. Oh, it might be possible there is no digit. If st dot top opening bracket or is not equals to a closing bracket, eh, should be and perfect. Okay, great. So what we did in this question, we broke down this question into smaller pieces. We started from very small piece
and then we started to build upon that. Slowly and slowly, we thought our thought process was something. If this is the case, then how we'll do it. If this is the case, then how we'll do it. So that was our thought process, and after that, gradually we were able to solve this question. So nice. This is something great, something new we learned. Okay, let's take a 10 minutes of break, and after break we'll start. Hello, I'm back. Shout out, you ignoring? No, bro, I'm not ignoring you. Me going bye bye. Soja, me angry. I will unsub. Bro, don't be angry. It's not watching you as solving the question. That's why. Don't go. I am going for a 10-minute break, and you stay. Be back after 10 minutes.
Hello, I'm back. Just a second. I am not able to sit properly. Okay, let's go. Let, let's try and solve one more question. We solved this blind number of atoms. It's good, 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 good. Count fertile pyramid in a land. Should I go for this? Should I go for this? Should I go for this? Which one should I go for? The one who's watching, can you tell me? Which one should I try? Count fertile pyramids in a land sequentially. Ordinal rank tracker. I think I'll go with this. Maybe कुछ ज़्यादा weird लग रहा है ये. Okay. Let's read the question. Okay, the question says a farmer has a rectangular grid of land with m row and n column that can be divided into unit cells. Each cell is either fertile, represented by 1, or barren, represented by 0. Cool. A cell outside the grid are considered barren. Okay, there is a cell and outside also there is something. That is what he is trying to say. Cool. Let's see. A pyramid plot of land can be defined as a set of cells with the following criteria. A pyramid plot of land. The number of cells in the set has to be greater than 1. The number of cells in the set has to be greater than 1 and all cells must be fertile. Okay, and all cells must be fertile. The apex of a pyramid is topmost cell of the pyramid. Just a second. So the apex of the pyramid is the topmost cell of the pyramid. The height of the pyramid is the number of rows it covers. Let R, C be the apex of the pyramid and its height be h. Let R, C be the apex of the pyramid and its height be h. Then the plot comprises of cells I, j where R. Oh, what in the world are it? Why there are so many equations? Has to be greater than 1 and the cell must be fertile. The apex of the inverse pyramid is the bottommost cell of the inverse pyramid. The height of an inverse pyramid is the number of rows it covers. What is this inverse pyramid? Pyramidal pyramid will be something like this. This is a valid pyramid, this is invalid, this is invalid, this is invalid, and this is a valid pyramid. The number of cells has to be greater than 1. And all cells must be fertile. The apex of the pyramid is the topmost cell of the pyramid. The apex of the pyramid, this is called maybe the apex of the pyramid, the topmost cell of the pyramid. The height of the pyramid is the number of rows it covers. The height of the pyramid is the number of rows it covers. 1, 2, 3. Okay, number of rows it covers, sorry. So 1 row, 2 row and 3 row. In this only 1 row and 2 row. The height of the pyramid is the number of it covers. Let RC be the apex of the pyramid. This is the apex of the pyramid. And the height is number of rows. Then the plot comprises of cells ij, of cells I, J, where R lesser than equals to I lesser than equals to R plus H minus 1. What is this? What is this? Then let's try to understand this. Then the plot comprises of cells I, J, where I. Okay. Apex of the pyramid is R, comma C, and height is H. Then the plot comprises of cells I, J, where R is row. Where R is lesser than or equals to I and lesser than equals to R plus H minus 1. And J is C minus I minus R, C plus I minus R. And if it is a inverse, then everything will be just opposite. So I and R will switch its places. I think rest will be same. This one and this one will change, switch its places. So how many total pyramids and inverse pyramid can be found in a grid? That is what we need to find. The two possible pyramid plots are shown in blue and the red respectively. One is this pyramid, and the other one is this pyramid. This is one pyramid, this is pyramid. We even have to find so we need to find straight pyramids and inverse pyramid both. How many straight and how many inverse pyramids are possible. Again, the pyramids are varying. Pyramids are varying. Now, how to recognize whether it is a pyramid? Now, this is the apex of the pyramid. And this is the height of the pyramid. Apex of the pyramid is RC. Height is H. So at least, okay. So one key observation is, if we want to make a pyramid, one observation is let's just take the smallest pyramid possible. Let's try and break it down. So the only possible pyramid is of size 3. Height, minimum height should be minimum height 2. Now minimum width should be 2. Then only we can consider them as a so if we have 1 1 1 1 1 1, what we can say, we have had to start from so depending on height my width will also switch, correct? If my pyramid is of height 2, so this is my RC, what it was saying. Now suppose this is my IJ. I should be greater than or equals to r rho. Correct. So I should be greater than or equals to the rho to form, and I should be lesser than r plus h minus 1. Height is 2. So r plus h minus 1. R rho is 1 0. Height is 2. 2, that is 1. Now j. For j should be greater than or equals to c minus c minus I minus r. What is this? There's something hidden in this only. If j is lesser than or equals to c plus I minus r. Why there are so many mathematical operations? There are lots of mathematics involved in this. 1 pyramid, 2 pyramid, 3 pyramid, and then height increased. Hmm. Let me try for some dynamic programming DP question maybe. This is a DP question. It's really irritating question. For each row, we store the number of ones above and below in separate tables. Number of ones above and below in separate tables. After this, the problem boils down to calculating the number of triangles in a histogram. Top ones and bottom ones. What are we exactly doing here? Top one is doing what, bottom one is doing what? If top one of 0j, if I 0, top one or grid, ठीक है, else if grid ij, current grid ij is 1, so top one में होगा 1 plus just above वाला. और अगर नहीं है तो we are breaking from there. And bottom one, get possible parameters, top one. Okay, let's understand this, what he is saying. This is top 1, so it will be 1 1 1. This will be 2, this will be 2, and this will be 2. If I take this, 110 122. So for top one, I have to find a triangle. And now he's saying, go up. We store the number of ones above and below in separate tables. After this, the problem involves calculating number of triangles in a histogram. Number of left triangle, number of right triangle. Finally, we take the minimum of left and right triangle as number of pyramid. As we are also calculating as a single triangle as well. As we are also calculating single node as a single triangle as well, the so I have this top one. I created a left DP. Zero or one row. Acha, we are sending row by row. So first we sent this row. And then we send this row. We send this row left DP of I, and this is for left DP and this is for right DP, and whatever finally will add in my result and return the result. This is what he is doing. Left DP of I minus 1 plus 1, or row of I. We have this row and this is my left DP that I am making, and then we'll make right DP. The left DP is starting from 1, minimum of 1, or this row of I minus 1 plus 1, that is so this is saying what? टॉप से कितना लेंथ है? अभी यहाँ पे 1 होता तो टॉप से 10 होता, क्या 10 ट्राइंगल होते हैं? आई एम टेकिंग मिनिमम. एंड रो ऑफ आई, तो यहाँ पे 2 हो गया, यहाँ पे 3 हो गया, और यहाँ पे 4 हो गया. राइट डीपी भी सेम 1 2 हो गया, यहाँ 3 हो गया, यहाँ 4 हो गया. वन 2 है. तो यहाँ पे 2 माइनस 1 1, 3 माइनस 3 2 माइनस 1 प्लस 1 1 है, 1 है, तो 2 तो आया मेरे रिज़ल्ट में. अभी इसके लिए अगर हम देख, इसके लिए लेफ्ट टीपी क्या बनेगा? 0 0 प्लस 1 1, और ये 2 1. अब 1 प्लस 1 2, और 2 प्लस 1. 1 मिनट, लेफ्ट टीपी राइट टीपी गलत भरे ना. 2 प्लस 1 दैट इज़ 3, और 2 2.
2 plus 1, that is 3 or 2. 1, 2, 2. Okay, so it is creating something right angle, left right angle, and right angle, and then combining it and then creating a pyramid. Something like this. Is there some other solution also? Okay, this is a solution. Find the pyramids assuming the current cell as apex. Find pyramid. Find the pyramid assuming the current cell as apex. I'm trying to find a pyramid assuming the current cell as apex. Fine. What should we do here? M grid n. We are starting from bottom and we are going up. I is greater than or equals to 0, I minus. I is starting from bottom, j is starting from 1. Okay. Now current cell as apex. If I am thinking 0 1 1 0 1 1 1 1. If I am starting from here and I am assuming that current cell is this is the apex. If grade of ij is 0 or I plus 1 of j is 0, that means if this is 0 or current value is 0, I'll continue. Minimum of grade. Okay, I'm not even starting from here because I need at least 2 to sell. So I'm starting from here. This is 1 and the next is also 1. Sorry, I plus 1 is this value. If this value is 0 or this value is 0, just simply continue. If these two values are there, I need to check these two. So minimum of I plus 1 j minus 1, I plus 1 j plus 1. Out of both these, minimum will be added. and grid of ij will be 1 plus these two, and result will be mini. This one is only thing that I need to understand. Grid of ij is equals to 1 plus, if it is 0 then 0 plus 1 is updated here. If they both are were 1, so 1 plus 1, that is 2, will be updated over here. This is it will be again, this 2 will be updated here. If suppose there were more values, 1 1 1 1, and this is also 1 for now. Let's take, I'll start from here. This is minimum is 0, 0 plus 1, that is 1, minimum is 1, so mini will be added, means this will form of one triangle. If this would have been also 2, there were few more values and 0 0 0. So for this is 2, this is 2, that means what, there was a small triangle, there is a small triangle, and this one will also be 1, small triangle, and now these two are 2. Means what, this small triangle and total this big triangle, this is what he is adding. If this would have been 1 only, there will be a bigger triangle and not a smaller triangle. Okay, and this value will be updated with 3, because the next time if 3 3 3 3 is there, this is 3, and the second value is also 3. That means one more triangle. Okay, this question actually is a little trick type question, not exactly logical. Yeah. Means if there is a triangle, I am considering this as an apex. If I'm considering the first thing, this as an apex, then what we want, we need all these boundaries to be 1, correct? So we are checking this, and this value should be 1. If they both are 1, the minimum of these two will give me the answer, and minimum of these two plus 1 will be updated over here. If they all are 1, that means this will be updated with 2. That means what, in future, if there we want to make a bigger triangle, so minimum will be If this is 2 and this is 2, then the minimum is 2. So we'll add 2. How to? This is a smaller triangle, this will always be added, and this as a bigger triangle. These two will be added in our answer. So this is how we are approaching this question, considering just below value and also the above value. Okay, let's try and solve it. So this will be my result, which will be initialized with 0. So there will be two methods, which so total in total there will be two methods. Whatever it will give me result will be added for upper PYR. This one will be for upper pyramid, where my grid will be passed, and result plus is equals to lower pyramid, where my grid will be passed, and finally will return my result. So I'll have a upper pyramid, so in upper pyramid I'll fix this as a apex. So int m is equals to grid dot I'll start from bottom. So not from bottom, because that will I need at least 2 row and 2 columns just to make at least 2 row should be there. So I'll start from the second last row, I'll go till 0, and I'll reduce my I, and my column will start from 1. I'll go till second last column, and plus plus j. Now if my current value, grid value, is 0, we won't be able to make any pyramid with this. Or if current value grid I plus 1 or of j is also 0, we won't be able to make any pyramid. So we'll simply continue. So we will simply continue, correct? If not, so I'll take mini will be nothing, but if they both are 1, so we'll be taking minimum of grid of I plus 1 j minus 1 comma grid of I plus 1 j plus 1. So this now I have to create a result, maybe answer initialized with 0. So answer plus is equals to many, how many are there, and current grid ij will be updated with 1 plus of whatever many value is there, and finally we'll return our answer. Now the lower pyramid will work exactly same like this. We'll start from top. See, let me take all these. We in this case we will start from 1, row number 1. We'll go till m. Considering this index as a apex, we'll do plus plus I. We'll start our j. We'll start our j from 1 only. We'll go till n minus 1 only and j plus plus. If grid ij and grid I minus 1 j is 0, then we'll continue, else we'll go with I minus 1 j minus 1, I minus 1 j plus 1. So I minus 1 j plus 1. Okay. Just a second, we are taking this as pass by reference, should not. Okay. Okay, this was a little trickier side question. I would say this was not very difficult, but yeah, you will have to hit and trial and see, okay, what to do next, what should be the case, what should be the this case. Uh, go by making 3 cross 3 grid, then 4 cross 4 grid, then 5 cross 5 grid, and then with few examples and test cases you will be able to understand, okay, what we are exactly doing over here. So these things are just for I would say for you to make you afraid of, but these were not very much useful. They were just making you afraid. Okay, yeah. So this is it for today. I think we already solved many questions. Maybe I'll paste this also in the description. We solved many hard level questions today. We also have a contest at 8 p.m. So I'll take a break right now, and after taking a break, and we'll be
I'll go with the contest question today and see how many questions I'll be able to solve. Okay guys, so this is it for today. I hope you liked the video. If you liked it, do please do like, share and subscribe my channel. I'll be posting many live videos in the coming weeks every Saturday. So hope you will meet there. Okay. Bye bye. See ya.